Yeah, hello guys. Good evening. Good evening. Join in for another new module. So some concepts from the numbers module is what I'm going to discuss today. Good evening, everybody. Join in. So as usual, night at 10 p.m. So we are discussing some of the important concepts, most impactful concepts that may come in the exam. Right? That's what we are trying to do as a part of CAT 21 prep. Yeah, sure. All of those who are appearing for CAT 22 as well might make some sense because I'm not discussing from the beginning to the end kind of, rather I'm trying to discuss in this the most impactful concepts from the quantitative aptitude. All right, so join in. Meanwhile, let me check. So who all have joined in and what is the audio video situation out here? Let's quickly take a look at that. Let's take a look at audio video situation, then we'll get started. Yeah, I'm good. I'm good, Keval. Thank you. Thanks for the concern. I'm good. Good evening, guys. Join in. Join in. That's nice. Rishabh has joined in. Ayush, Shivani, Efafra, Rishabh. Yeah. Yeah. Good evening, friends. Good evening. Good evening. Yeah. Keep a book and a pen, all of that ready so that you can take your running notes. So I will give the class structure, how I'm going to deal with this. I will give the complete class structure. So in the sense, like, of course, I will not do the complete numbers per se, but then I will be doing from the perspective of the, so whatever I am planning in this, I will give a kind of a structure on remainders alone so that you will be able to understand how we are going to deal with this in about a week's time or so. Okay, so there we start. Before you settle down, all of you keep settling down as I give my introduction. So here I am, Belvi Srinivas. So yes, I did work. I've been working in this industry since 2007. That's about 14 years now. And yes, I did develop expertise to train students in a QA, DI, and LR. I'm fairly good at verbal as well, but training is different from knowing. Knowing is different, training is different. That's what I believe in. Therefore, yes, I'm doing a strategy session on how to improve on VARC this weekend. I'm of course doing a strategy session. So with my limited understanding and the wisdom and based on whatever I've counseled, I'm doing that because I'm okay. I'm okay at that. All right. I don't say I just don't know how to train. That is it. Otherwise, I'm okay at that particular skill. Yeah, that's a little bit of my background. Yes. So here, a lot of you are inquiring about a dedicated Telegram ID so that we can post the things out there. So here is the dedicated Telegram link. You can use this link. So if you don't want to be on the generic link, you can put on this link. I'll send all my notifications, etc. on this particular link. Try this out. All of you try this out. If there is any issue, let me know. Not right now. Not right now. Don't try to deviate much right now. Maybe at the end of the lecture, you can come back. You can put it in and then you can join that particular link. Yeah. Some of you, those who are hands-on with the things you want to join right now, doesn't really matter. That's up to you. Yeah, had I been you, I'm not so hands-on with the things. Yeah, I'm okay, but then not that great. So therefore, I would say I would have done it after the lecture from my perspective. All right, good. That's a little bit about the background. So let me give a class structure, what I'm trying to do out here before I do my announcements. So numbers, technically numbers, you can call it as number system, number theory, doesn't really matter which way you kind of call it. I'll just simply call it as numbers because some people call it as number system, some people call it as number theory, whichever way you call them, whichever the book that you are referring, whatever the names that you are giving, right? So therefore, I'll just call it as numbers. Okay. So there are, if you say that, okay, what are the what are the major studies here? If you look at the CAT questions from 1992, if you simply look at the classification of CAT questions 1992 to 2020, let's say, all right, 2000, let's say 2020, all right, 2020. If you look at them, particularly you can put them as, hey, divisibility and its applications, right? Yeah, it is not about knowing the divisibility rules. So technically, it is about divisibility and its application. Application part is very, very important for CAT, right? It is not about knowing the rules alone. Divisibility and its application. What it means, it's a huge area. I don't want to get into the depth of it. That's one area. The second area is LCM, HCF. There are a lot of LCM models, HCF models. Quite a few applications come from there. LCM, HCF, basically it's application. Nobody asks you to find out, tell me the LCM of the numbers, HCF of the numbers. Hey, it's not a kid's play. It's not a kid's play. There are beautiful applications. So from level 0 to level 3 questions can be created on LCM and HCF, which all featured in CAT. All types of questions are featured in CAT, no doubt about it, right? Yeah. Third one is the factors of the numbers. All right, third one is the factors and its applications. Okay, what can be done? See, it's not about the factors. If you look at this, hey, when do you study the divisibility? Class 5, class 4, all these are class 4 onwards. Your relationship starts class 4 or class 5. LCM, HCF, maybe class 5 onwards. Factors, class 4, based on the different boards. What I'm saying is, hey, you heard these words and you started your association with these words from class 4 or class 5. I'm not kidding. Go back, whatever the boards you've studied. If you get that book, take a look at that particular book. You come across these words and you start your linking association with these parts from class at the age of 10. Technically, I'm trying to say that when you are at the age of 10, that's when you start this particular study and you mature in this study. You start. So where the divisibility, of course, in the 10th standard also it comes, right? LCM is there in the 10th standard also. You mature over a period of time. That maturity is what they are checking through the application. What they are checking is, hey, how mature you are, right? Are you only still knowing the basics, or you matured in that particular skill? That is what they kind of trying to test us there. Fair enough. So these are the three parts. Four parts, of course, it's a subset of divisibility, but yes, it requires a special attention. We call this more or less remainders. Let remainders and its applications. Right, applications can be to find the unit digit, to find the last two digits, to find the last three digits, all that. There are so many applications. If I want to list the applications, this is huge in itself. But concept-wise, there are only four concepts. All right, if you look at the CAT from 1992 till 2020, if you classify them, I would put them into these four baskets. One, divisibility, and build some questions built on divisibility. It can be level 0 to level 3. All right, level 0 to level 3, wherever you want to place the question. Same happens with LCM, HCF, ditto with factors, ditto with remainders. Now, out of this, I'm just picking out here. That's it. So you may say that, sir, what about the classification, etc., etc.? They are all fillers. Now, these are the boulders. These are the big ones. These are the boulders. Now, between the boulders, you want to put some fillers, put them there. They are called fillers. I want to put some pebbles here. I want to put some pebbles. Yeah, those pebbles are there. I'm talking about the boulders. Boulders first and then pebbles. I should not be busy gathering pebbles. Forget the boulders. First gather the boulders and then packing them with the pebbles, right? That's what you mean by classification, prime, odd, all that stuff, all that stuff. Okay, yeah. That will do for CAT 22. If anybody preparing for CAT 22, pebbles all covered there. I'm covering boulders as a part of this particular series. This is what I would be doing. This is what I'm starting now. So under remainders, there are three types of questions. Three, if I want to broadly classify them, my number, say what is the divisibility algorithm? It is this, a number when divided by divisor. There is some quotient, wherever you want to write it quotient. I am interested in remainders. In this question, nobody is interested in quotient. What are the three things we are interested in? Number, I am interested. Divisor, I am interested. Remainder, I am interested. Generally, these two are given to us. I am circling them. Divisor is given. Number is given. Number is called as dividend. Right now, number is given. Remainder is what has been questioned. Okay, what are the shapes of the number? Whatever be the divisor, number can be an exponential figure, a raised to power b. They will give some big number, not some small number. Hey, I'm a high school student, do some division. No. And then they will say that, okay, you find this remainder. All right, that is one shape. Yeah, what is the second shape? Second shape can be factorial. They will say that I will give you a factorial. So I will give some divisor. Therefore, you tell me the remainder. Right? Factorials are big because already even if I say 20 factorial, it's mind-blowing number. 20 factorial, our mind can't imagine what is 20 factorial because we imagine till billion and trillion. Beyond that, our mind cannot fathom what we are trying to say. After trillion, I don't know what to tell them, right? So that's what it is. 20 factorial itself is a massive, massive number. But in the exam, they use 100 factorial whole square, all that stuff. So mind-blowing numbers they use. Similarly, whenever we are talking about A power B, it's a mind-blowing number. They will say something like 89 raised to power 89 divided by some divisor. Nobody can ever understand what is 89 raised to power 89. We have very finite understanding. With that understanding, 89 raised to power 89, don't know. We don't know what to call that unless it's 18 raised to power 89. Okay, what is the third kind of number? There will be a pattern based number. Third kind of number is they will say that, hey, 1 2 3 4 1 2 3 4 1 2 3 4. They'll give some pattern. They will say that I will write up to 600 digits. Well, there are 600 digits in this particular number. Again, mind can never understand what do you mean by 600 digits in this particular number and trying to say that tell me some remainder after doing the division. Now, first and foremost thing, listen very, very carefully. What we understand, what we don't understand, because a lot of people don't even understand that. You should never ever pay attention to the number. You don't decide whether to do a problem or not to do a problem by looking at the number. That's the first thing. You decide whether to do a problem or not to do a problem by looking at the divisor. Divisor is what you need to be knowledgeable about. Number you don't know, all right, because I will write a number 89 raised to power 89. Who understands? Nobody on earth understands this number. Honestly speaking, nobody on earth understands this number. That is my true understanding. If somebody claims that I understand, sure. As far as I understand, nobody understands this. Similarly, you write 89 factorial. Nobody ever understands what is this. Yeah, 89 factorial is 89 factorial. You write that particular number. So nobody understands what to call that, what to say that, right? That's a reality there. Therefore, what? You don't make a decision based out of number. You make a decision based out of divisor. That's a point there. A lot of people forget this. They fall for the number. They will look at the question. Man, what is this massive kind of number? I ever don't know. I have not seen anything like this. No, look at the divisor. You understand something about the divisor, then do that problem. You don't understand something about the divisor, better don't do that problem. It's as simple as that. Okay, that's my point one. So now what are the three types of problem? One is an exponential number. So whatever be that, you have a divisor, no doubt. You have a divisor, no doubt. But how does your number look like? One is an exponential number. Second, a factorial number. How to deal with the factorial number. Third, how to deal with a pattern based number. Whatever. A is a digit, B is a digit, C is a digit, D is a digit. You are kind of writing A, B, C, D, A, B, C, D, all of this. Right. So something like this up to n digits. There are some n digits in this particular number. So I am going to deal with all these three parts. Of course, I'll be starting with the properties. Even before I get on to all these three parts, first I will illustrate properties. See, I will tell you why. Why properties? Whatever the number of remainders questions you came across so far in the exam, I've seen the papers from 1992 onwards. Whatever the questions we have seen, half of the questions on remainders on these three patterns. See, again, I'm not saying half of the numbers in numbers, because numbers I already classified into four baskets, right? This is one basket, second basket, third basket, and fourth basket. Now I'm only talking about the fourth basket. Whatever the questions came under the fourth basket, half of the numbers were simply based on properties. They were based on properties, not based on theorems. Properties versus theorems. Okay, if half is exaggeration, definitely 40%. As far as I remember, it is 50%. Okay, fine. If you think it's an exaggeration, let's put it as 40%. Definite. 40 is definite. My guess, it should be somewhere about 50%. Okay, so it's simply based on properties. Why so? Because number theory, people study in the 11th and 12th standard. CAT always said that a base is going to be high school. Who studies the theorems there? Or do you study something about too many theorems out there? No. Therefore, properties versus theorems. Half the time they talk about properties, half the time they spoke about theorem. So what I will do now? First, I will start with the properties, because if I do with the properties, 40% of my job is done. For the remaining 60%, I got to learn certain theorems, right? Yeah. What are the theorems here? Couple of 3 or 4 theorems, and its applications is what I want to see. Theorems are pretty simple. One of them we call it as a Fermat's theorem. The other one of them we call it as the Euler's theorem. Both the theorems we'll use to attack this. And here we make use of the Wilson's theorem. In addition to common sense, common sense is nothing but the properties. Knowing the properties means having some common sense. So beyond common sense, I use these theorems. 1, 2, 3, 3 theorems. For this, I use the factor theorem. For this, I use the factor theorem. I will come to that. Okay, these are the kind of 3 or 4 properties that we use. Now, beyond this, some people use the Chinese remainder theorem as well. But the applications are really, really rare. All right, yeah. So now these are the things. This is the class structure. This is what we are going to do out there. So if you are noting it down, probably you can take a screenshot of this, or this is what we are going to study. Anytime you study remainders, these are the salient features. That's it. If you look at this whole of numbers, how many questions come? Whole of numbers, about 2 or 3 questions come in CAT. In the entire numbers. Out of this, what is the chances of remainders coming? Maybe 1 question or 0 question. That's a reality. First, let's understand the reality as well. Now, don't think that, hey, this much study we are doing, what are the chances? Chances are 0 or 1 question. Chances are 0 or 1 question. That's the reality out there. Let's go with 1, because more often than not it is 1. Let's go with that, because there are 4 areas. Between the 4 areas, they can give 2 or 3 questions. Two things called this year. They may say that, hey, I will ask questions on LCM and factors. Therefore, no remainders, only 2 questions I ask. No, I will ask 3 questions. Fair enough. 1 on LCM, HCF, 1 on factors, and 1 on remainders. I don't know which way it is going to be. Okay, this is the reality. This is the crux of the story. You got the background, what we are going to do for the next 1 week in the quant? Quick, everyone. You got the background as to what we are going to study in the next 1 week here. Next 1 week story on the numbers. Clear to you? I give a structure for next 1 week. This is the structure for the next 1 week for us. Yeah. All right. Hey, what's your name, man? At most experience. Would you mind putting your name there? I think yesterday also you were there. Glad to have you, no doubt. But then I would love to call by name or at least remember by name. Yeah, some of these are fancy ones. Who was using that before? Drop out something? Was this cable? What was that? Somebody was asking that, putting that drop out something. Who was that? Okay, at most you are Kushagra, all right. Who was using that? Drop out something, something was they were using, and then like you changed it to your name. Who was that? It's not cable. Okay, somebody else. Somebody else was using that. Okay, any which way, it doesn't matter. Yeah, yeah. Some of them are pretty fancy. I mean, that was one of the fancy one. Yeah, dropout kit. That's right. You only, is it? Okay. You keep coming with fancy names, Kushagra, all right. Dropout kid, whatever. All right. Okay. So let me do quick announcements before I get into the lecture because I don't want to break out of the lecture once we get in there. Yeah. So Unacademy offers two kinds of subscriptions, Plus and Star. Star is nothing but iconic. Don't call it as Star. Yeah. Plus is about the structured courses. Yeah. I will be soon starting the structured courses by the mid of this particular month. Okay, I will let you know about those details maybe by tomorrow or day after tomorrow. So I will be taking in the structured courses. Yes, I'll be starting from zero and going up to level three. All right, because sometimes on the YouTube platform it doesn't allow me to go through level three. Level three, all kind of users join in there. But in the structured courses, yeah, all right, we will hit somebody looking at 99.5 to 100 percentile. So how does that look like? That story look like? What concepts they also should know in addition to whatever we are doing here. Well, that's what the plus course does, and most of it I will be launching individually. I'll be doing it myself individually. I'll be doing some of the courses that gives me a lot of flexibility, right? That's what I believe in. Yeah. So structured courses, then you have weekly tests. So pretty particularly, all at the structured part of it. Iconic gives a lot of personal attention. In the sense like you are looking for one-to-one test analysis or one-to-one guidance, one-to-one doubt solving, one-to-one concept solving, whatever is that, right? So it's more to do with the one-to-one interactions, pretty good number amount of one-to-one interactions. Yes. So you a six months course might, so these are the different subscription it offers. CAT 21 might be useful for CAT 22. This could be for CAT 22 or CAT 23. All right, that's our or CAT 23 spec. All right, these are the three kinds of subscriptions. So if you use code, any user code, including my code, you get 10% discount. So not 100% discount. Code looks like Belvi 100. Don't expect 100%. It's about 10% on these listed prices. Whatever is listed on this, you get about 10%. Iconic subscription, on the face of it, it looks a little heavy, a little costly. Yes, but then there is so much of one-to-one interactions involved there. So that is worth that. Yes. So if I were you, so if I'm looking for some subscription at this point in time, CAT 21, it's better to go for this because you need lot of one-to-one interactions, right from application form filling to the B school selections. You might need already quite a bit of support with the mentors. So one or two people you might have to consult one-to-one quite often. That's required. That's required. That mentoring is required. Wherever it is, here, there, doesn't matter, but it is required. Just keep that at the back of your mind. Your prices are set to go a little high from 16th of September. Right, that brings us to the end of our discussion. So now let me go to the properties. Let's start with the properties. Keep the notes, keep the book with you. Yeah, keep book and pen, keep trying to take the running notes so that you don't run out of space. So before I get into any of the theorems, etc., I will spend some time because these properties, using just these properties, 40% of the questions under remainders can be solved. Now, this is the verified truth. That is minimum in upward of 40%, right? So I'm saying that's a bare minimum because you cannot prove me wrong on this figure for sure. If I say 50%, probably you might prove me wrong. I've not really done that statistics. Yeah, but then that's the truth. Okay, fair enough. So that's the background there. So what are the properties? One is the property of isolation. When you are looking at the properties, first one is the isolation. So we use this isolation property quite a big time, right? Isolation. Even that when we go to the theorems as well, these properties will come after applying. The first step is the theorem. After applying the first step of the theorem, I listed some theorems there. First step is the theorem. After that, what? After that, properties only, right? So it is not that you will be able to close the question with the theorem. No, you won't be able to close the question with theorem. Theorem first, and then you will come back to the properties. Therefore, undercurrent is properties. And hence, I need to understand these properties. First property, I call it as an isolation property. What is this? If there is a number, say that there is a number 1 into number 2. Okay, so I will write this like this, my friends. For example, a number when divided by a divisor leaves R as the remainder. So what we are not interested in this study, quotient we are not interested. How do I represent this? I represent it like this. Number when divided by divisor leaves R as the remainder. I write like this. Different people write it differently. Allow me to write like this. This is how I will write. So get used to it. Don't read this as numerator, denominator, simplify. No, I didn't mean that simplify. If you have a numerator, denominator, you will simplify. The division, you will not simplify. For example, don't tell me this. For example, let's say that, okay, if you have 8 divided by 6, 8 divided by 6, what is the remainder? Don't try to simplify. Okay, 2 3 times, 2 4 times, 4 by 3, 1 remainder. Wrong. You are not simplifying. In a division, you don't do that. Hey, it is 6 and it is 8. 6 1 times 6, please tell me 2 as the remainder. Don't try to cancel anything, because I may represent like this, but don't confuse this as the numerator denominator. It's not numerator denominator. Instead of writing like this, I choose to write like this. But don't treat it like a numerator denominator trying to simplify the stuff. Don't do anything. 8 divided by 6, remainder is 2, period. That's it. Don't try to simplify and give me some answer of your own. All right, yeah, that's a word of caution, because sometimes in a mind, or in a fit of hurry, so what happens is you suddenly look at something and you think that numerator, denominator, let me quickly simplify them. No, it's a number and the divisor. Okay, what is the isolation technique? First, let's come to the isolation property. What is the isolation property? If I have couple of numbers, number 1 into number 2 into number 3 and many more, let's assume that first to start with the multiplication. You have to multiply all these numbers and then divide by a divisor, and then you have to list the remainder. We will never multiply them. Rather, what we do, all right, this is the property from your high school. What I'm saying here, nothing new. Number 1, divide by divisor, put the remainder. If it is into, put that into there. Okay, what is that into? This into you capture. Then you will say that number 2 divided by divisor, what is the remainder? Then put this into there. If it is into, put into. If it is plus, put plus. If it is minus, you put minus. Right? Yeah. Number 3 divided by divisor, what is the remainder? Put them together, multiply those remainders. That becomes your answer. Right? That is called as the isolation technique. For example, classic example. Say if you have 421 into 422 into 423, when divided by 12, what would be the remainder? Let's say 421, 422, 423, when divided by 12, what is the remainder? What we do, we don't multiply them. You multiply all of this and you get some 7-digit number. From that 7 or 8-digit number, you are trying to find an answer. Of course not. So all I do is what? 421 by 12, what is the remainder? If it is into here, therefore I bring back that into 422 by 12. I will figure out isolation. What is the remainder? Then I will bring this down. 423 divided by 12. I will figure out what is the remainder. That will be my net remainder. Fair enough. So 1 is the remainder here, because 3 times 36. Then you have 61. 12 5 times 60. Therefore 1 is the remainder. 2 is the remainder. 3 is the remainder. This portion leaves 1 as the remainder. This portion gives 2 as the remainder. This portion 3 as the remainder. Where are these intos coming from? From here. 1 into 2 into 3. Therefore, my answer is nothing but 6. Right? So that is what we kind of do. What is this called as? This is called as isolation property. Right? Where did we study? High school. Right? Where did we study? High school. Because if the quotient you are interested in, then you may have to consider this. If you are interested only in the remainder, you don't have to consider this. This is how you do. Isolation property is what you kind of going to use there. Fair enough. All right. Hey, come back to the same question. Let's say that in the same question, hey, what if this particular number was 421? Call it 421. Then you have 425 minus 425. Let's say plus 423. So you can add. Now the numbers look like pretty simple. Fair enough. Because in the future, I'm going to write 21 raised to power 23 minus 23 raised to power 79 plus all it now. So that's how you are going to write something there. Then 89 raised to power 463 divided by something like 12 or whatever. What is the remainder? Now these are two big numbers. For the time being, these are symbolic of what we are going to get in the future. In the future, this is what we are going to get. Right? As of now, this is what we are going to get. That is the point out there. Fair enough. So I want to add these numbers and give the remainder. Do exactly same thing. There is a minus here. Bring this minus. All right, there is a plus here. Put this plus back. Put this plus back. Fair enough. So you got 1. You got, all right, now this is 124, 25. Therefore, you got minus 5. And you got plus 3. You got plus 3. What is the complete remainder then? Minus 1. Hey, can a remainder be negative? No. If you get a negative remainder, what you should do? Add the divisor. Therefore, I will come back. I will put the plus. Plus what? What was your divisor here? 12. Add the divisor and call the final remainder as negative. This is called as negative remainder concept, because when you use this isolation property, you may end up getting a negative remainder. Quite likely, possible that you might end up getting a negative remainder. Fair enough. In this case, I got a negative remainder. What did I get? I got the negative remainder as -1. But final answer, remainder means something left out. Something left out cannot be negative, right? So answers cannot be negative. After giving a question, they will give a box. Say in this box, you may have to fill it. You can't fill a negative number. The remainder means something left out. Something left out can never be negative, right? Yeah. Food is left. Left out is cannot be negative there. Left means something positive, right? Yeah. So therefore, -1, how do you put that? You add the divisor back to it. That is 12. You add the divisor, you get the positive remainder. Right, fair enough. So I hope all of you are getting this particular point. Yeah, what if all right now something's like, okay, this is 421 into 425 into 423. I got something like this. Let's assume. Okay, if you get something like this, you do into here, you do into here. So therefore, you are getting into here, you are getting into here. What did you get now? You said that remainder is 15. I will laugh at it. If you say that after doing this particular question, I got 15 as the remainder, I will laugh because, hey, when you divide by a 12, how can you be left more than 12? Your remainder has to be necessarily less than the divisor. Necessarily less than the divisor. It can't even be equal to divisor. It has to be less than divisor. I will say that why you have listed something more than that. Fair enough. What you should do then, come back, divide by a divisor. Alright, if you think that the remainder has exceeded the divisor, come back, divide by it. Alright, you will get a 3 as the remainder. Okay, what I'm trying to say, in the isolation technique, while you are applying the isolation technique, these are the variations that can happen. You might end up with a negative remainder. You might end up with a remainder which can be a laughing substance, which means you got something like 15 when you divided by 12. Don't laugh at it. You know the concept that remainder has to be less than the divisor. Come back, divide by the divisor, you get the value as 3. So therefore, let me conclude this. Say how does it look like now? It can be into, it can be plus, or it can be minus. It can be into, it can be plus, it can be minus. Any symbol can be used between any kind of numbers. Use exactly same symbol there. Use exactly same symbol there. Watch out if you are getting a negative remainder, make it positive. Watch out if the remainder is exceeding the divisor, make it smaller, right? So these are the things that you do there. This is called as the first property, and isolation property. Clear? Everybody clear with isolation property? High school stuff clear? We will see the application. We will see the application, but the property is important. This is called as isolation property. Fair enough? Fair enough? Quick reminder, everybody. Clear there? Anybody want to ask anything? Let me know. Of course, I'm assuming that you will know it, but I don't want to take it for granted. That's the whole point there. Because I get into the application, then I will say that based on isolation property, then one of you will be wondering which isolation property this fellow is talking about. What was that? Right? So I don't want you to wonder that time. Therefore, I'm making it clear, because in the complete 7 lectures, whatever we are doing, 4, 5, 6, 7, doesn't matter how much we do. So I will be calling this name based on isolation property, courtesy isolation property. Then you should understand. Otherwise, you think that which kind of isolation is this, right? Because we are all used to COVID isolation these days, right? So I don't want to be misunderstood with that. Fair enough. Anyway, second one. Second one, quickly, let's wrap it up the properties. What is that? Given that, listen, we also know this. Given that when a number is divided by a divisor, all these are high school properties I'm reiterating to you. Number divided by divisor leaves R as the remainder. Right? A number when divided by divisor leaves R as the remainder. When k times of the number, therefore, when k times of the number is divided by the same divisor, the remainder would become k times of R. Right? That's another property that you studied. The given, all right, now what is given? Given a number when divided by divisor leaves R as the remainder, then k times of the number when divided by the same divisor leaves k times of R as the remainder. Assume that I don't know anything. I have a number. I told you, hey, I divided this by 11, man. I divided this by 11 and I got the remainder as 2. Fair enough. Now I'm asking you a question. I gave this given a number. I don't know what is that number. It can be a big number, small number. I don't know. A number when divided by 11, 2 is the remainder. Then I said that, hey, what about 5 times of the number divided by the same divisor? Answer simple. 5 times of 2, because you know the outcome is 2. Make it 5 times of 2. Therefore, the answer is 10. Is 10 less than your divisor 11? Yes. Therefore, answer is going to be 10. That's it. Should I have to know the number for this? Absolutely not. You don't have to know the number for this. This is the second property that you studied. If you just want to quickly understand this, try it out something like this. Say 13 divided by 11. Just an example. 13 is the number. 13 by 11, 2 is the remainder. Okay, double this number. 13 into 2, or 2 times of 13, we know that that's nothing but 26. Divided by 11, 4 is the remainder. We know that that's 4 is the remainder. Hey, what all it does, I'm just doubling it. Let me write 26 itself. Okay, what if I triple this particular number? 39 divided by 11, 11 threes are 33, therefore 6 is the remainder. Look what's happening. You doubled the number, remainder got doubled. You tripled the number, remainder also got tripled. Simple property, all right, from the high school. Yeah, it doesn't need much illustration there, but this property is important. Okay, point number 3, all right, the third property. Third property, given when the number is divided by the divisor leaves r as the remainder, then number raised to power k, all right, therefore, all right, then, technically it is then, when the number is raised to the power k divided by the same divisor, remainder will also get raised to the power k. Okay, word of caution, everything remains same. For example, come back to this earlier property here, my friends. There is a number when divided by a divisor, all right, when divided by 11, let me take it as 11, 6 is the remainder. Let's say if there is a number when divided by 11, 6 is the remainder. Okay, double this number, 2 times of the number when divided by 11, the remainder will be 2 times of 6. Of course, 2 times of 6, which is nothing but 12. Unacceptable. Okay, what was your divisor? 11. What is your remainder? 12. See, same things, whatever I said in the isolation property would be true here as well. That is 12 divided by 11, the remainder is going to be 1. Okay, therefore, same cautions, negative, positive, whatever I said there will be true here also. All right, that's going to be true here also. Always ensure that your remainder does not exceed the divisor no matter what. Okay, fair enough. This is the third property. Same thing can happen here as well, which means you may say that a number divided by 11, the remainder is 3. When the square of the number is divided by 11, the remainder will be simply 3 square. It has to be 9 there. Okay, that's a property. So I can give a simple illustration as well. For example, 14 divided by 11, remainder is 3. 14 square divided by 11, the remainder has to be 9. You can check this. 14 square is 190, 196 divided by 11. Check it out. Already you will get 9 as the remainder. 11 1 time 11. Therefore, you have 86, 11 7 times 77. Therefore, 9 is the remainder. Fair enough. Okay, that's how the properties run. Last property, which is most often misunderstood. Listen to this very carefully. For given when the number is divided by the divisor, leaves r as the remainder. When k times of the number is divided by k times of the divisor, still the remainder is going to be k times of remainder. Don't cancel. This is the matter of divisors and number. It is not the matter of numerator and denominator. Don't try to cancel and say that answer is going to be r. No, all right, when k times of the number is divided by k times of the divisor, remainder is still going to be k times of r. This is where I have seen a lot of people getting caught short while doing the larger problems, because when it comes to application, that is where they fumble, especially with respect to the fourth property. For example, you have 13 divided by, say, 13 divided by 11. 2 is the remainder. Double the number, double this, 26. Double the divisor, 22. What is the remainder here? This also got doubled. Because you doubled it, you doubled this, your remainder also got doubled. Check it, 26 divided by 22 is going to be 4. It is not a simplification. Do not simplify. Do not simplify. This is the business of divisors and remainders. Do not simplify. Word of caution. Do not. Okay, let me write do not. Otherwise, you will simplify. You look at the simplify and you think, okay, I should simplify. Do not simplify. If you simplify, you are finished. Do not simplify the things when you are trying to find the divisors and remainders. These are the 4 properties. Number 1, isolation property. All right, after that, you have the second property, the third property, and the fourth property. With these 4 properties, let's see some of the questions which appeared in CAT. How did they appear and how one should have solved them? Simple ones were there. Level 0, level 1, level 2, all kind of questions were there based on these simple properties which we are going to examine. Now, that's what we kind of look at it. Now, so before this, one important thing. Listen, everybody listen here. These are the 2 fundamental mistakes people do and they get stumped when the questions come in there. What are the mistakes here? Look at this. When the number is divided by divisor, so we want this number and a divisor. So a question asks this, what is the remainder? Correct. This is the one. Always preferred remainders. Preferred remainder. Listen to this word. I will explain what is this preferred remainder. This is the whole idea. All theorems are because of this. Note it down or put this somewhere in your mind. Preferred remainder is either 1 or -1. Why? We will come to it. This is the preferred remainder. Always you should hunt. You should look for. Always look for preferred remainder. All the things is to understand that am I getting a preferred remainder or not. Preferred remainder is either 1 or minus 1. That is called as the preferred remainder. Second thing, always ensure that the base, already if the number is of the form a raised to power b, if n is of the form a raised to power b, always ensure that a is less than d. Always ensure that a is less than d. These are the two important points. Two important points. Always watch out. Look for the preferred remainder. Watch out for the preferred remainder. Number one, I will come to this. What do you mean by this preferred remainder? Watch out for, because technically what consists is minus 1. 1 we will notice, minus 1 we fail to notice. Number 2, already if the number is an exponential number, if the number is of the form a raised to power b, always make the base. There is a base and there is a power. Power don't try to control base. The base you should make it always less than the divisor. Base should be less than the divisor. Even if they get the value of a base to be greater than the divisor, bring it down, make it lesser than the remainder. Okay, now these are the nuts and bolts of what we are problems that we are going to apply. All these points are clear, my friends. All points are clear. All points are clear. All points are clear. Nitesh, there is a lot of time. We will go to that point 4 later. Don't worry. We will not come across point 4 today. I said that it's a very critical one. We will come to it later. Don't worry. When the time comes, I will re-emphasize that. Don't bother. First, give me a quick understanding that, okay, we are ready with the tools. Tools are correct. Tools are clear. Tools are very clear. Let's see how effectively we use them on some of the CAT questions. Tools are clear. All right. Okay. Now, before getting into the CAT questions, let's do some warm-up. Let's do some warm-up. Before we get in there, let's do some warm. Do some warm-ups with me. Some of the warm-ups you can do with me, and then I will give you a little more time. Very good, guys. You guys are, that's a good thing. I like your batch. Right. So most of you, those who are attending regularly, you understand it pretty fast. That reduces burden on me. Right. So that reduces a lot of burden. Yeah, sure. Some of you put comments here and there. You want to explain something once again, I will. Sometimes I know that I will be anyway explaining this at a later stage. That is when I will give a bye. I will take a bye saying that I will explain it later. Right? Because I know that anyway I have to come back to that point, just like Nitesh was trying to ask something here. Okay, let's come back to this. What is the remainder when 67 raised to power 42 is divided by 17? It's a warm-up. This is not any CAT question or anything. I will do 3-4 warm-ups. Then I will open up to the question. Some warm-up is required on the properties. Now listen to this carefully. 67 raised to power 42 divided by 17. I said that first base. Man, I want base to be less than the divisor. First thing I said, when it is a raised to power b is divided by solid divided by divisor, what is the remainder? First thing I said, two things, always two things. What is that? First, make this fellow a less than d. First thing is this. First thing first. Always ensure that a becomes less than d. Second one is what? Look out for the preferred remainder. Watch out for the preferred remainder. Always watch out for the preferred remainder if it is an offering. Fair enough. So first let us see that. Okay, so these are the twin objectives when you are looking at this. These are the twin objectives. You will say that 17 into 4, 68. Where I'm looking at that? I'm looking at the base. 17 into 4, 68. What is 67 therefore? Preferred remainder is 1 or minus 1. I'm getting minus 1. Therefore, you say that a 67 when divided by 17, the preferred remainder is minus 1. Write preferred remainder. When 67 is divided by 17, preferred remainder. Always, these are the twin objectives while doing any question. First, you write the preferred remainder is minus 17. Okay, what did the property say? We know the property when a number is divided by divisor, if the remainder is r. When number is raised to the power k divided by the same divisor, the remainder has to be r raised to power k. Do exactly same thing there. What was your number? 67. 67 when divided by 17, the preferred remainder is minus 1. Therefore, 67 when raised to the power 42. Alright, then the remainder is also going to be minus 1 raised to power 42. What is minus 1 raised to power 42? 1. Is 1 less than 17? Yes, that is going to be my answer. Therefore, 1 is going to be my answer. Very, very simple. So hereafter, we may not have to write so much there. This is what we are doing. What property did I apply? This is the property I applied. This was the property. When a number, what was the number? This was the number. This was my divisor. This was my remainder. Number raised to power k. Where was the k here? 42. Therefore, I got the preferred remainder. Always I look for the preferred remainder. I wrote minus 1. Therefore, it became this. Never write 16. Don't write 16 raised to power 42. Okay, 67 divided by 17, the remainder is 16. No, if there is a preferred remainder visible, don't write the other remainder. Is this clear to you? Is this clear to you? What do you mean by why not plus 1, Nitesh? Why not plus 1? You are doing this 67 raised to power 42 when divided by 17. I am asking remainder. What do you mean by plus 1 in this question, my friend? Please explain me this. What do you mean by plus 1? Did you ever do something like that in the division? Which means your teacher gives you 19 when divided by 7. Please tell me the remainder. Or 20 divided by 7. Your teacher says give me the remainder. Do you write something plus 1 here? What do you mean by that plus 1 there? Yeah, it is division, man. It is division. Please, it's division. Don't take your eye off. When did you learn the division? Class 2, class 3, class 3. Right? Class 3 onwards, you have the relationship. Be mindful about it. Let's be mindful about it. Right? Yeah. Okay, that's a point then. We can use properties, but not at the expense of anything on the division algorithm. Right? Your teacher said, all right, now do something like 20, you divide by 17. Tell me the remainder. You don't add 1 to it and do some drama there. No, not at all. Not at all. Right? We don't do anything like that. The existing properties only I should use. I can't go beyond the purview of the properties, right? Yeah, I need to make use of all the available properties because they are proven, right? So I can't think something creative, right? No, we can't be creative with certain numbers and certain finances. All right, finances, you can't be creative. Bank balances or your balance sheet. If you are creative means what? You know what I mean, right? Yeah, you can't be creative with the balances already, your balance sheets, etc. It has to be spade, has to be called as a spade. Similarly, properties are properties in maths unless it is proven, right? If we want to use something new, first we got to prove it and then we will accept it. Okay, let's come back to this. What is the remainder when 84 raised to power 84 is divided by 17? Another warm up, let's do 84 raised to power 84. 84 raised to power 84 when divided by 17. All right, what is the remainder? Same here, all right, same here, minus 1. All right, because 184, very similar to the previous question. I hope by now you would have got the hang of this. 84 when divided by 17, the remainder is minus 1. Why? 17 5s are 85. Now this has been raised to the power 84. Therefore, minus 1 will be raised to the power 84. Net remainder becomes 1. Very similar to the previous question. I don't have to take much time to explain this. I can rush through. Yeah, here comes another question. Okay, let's understand this little better here. Let's understand this. 84 when divided by 17. You always take the base because I don't want base to be greater than the divisor. 84 when divided by 17, the remainder is minus 1. Fair enough. But author said it is 84 raised to power 85. Then minus 1 raised to power 85. You will get minus 1. After this question, there will be a box. You cannot type minus 1 there. Alright, inside that box, you cannot type minus 1. Your answer is minus 1. Remainder has to be positive. We already talked about it. How do I make this positive? Add the divisor. You got minus 1 as the remainder. Why? Minus 1 raised to odd power is minus 1. So, but then I can't type the answer as minus 1. Remainder has to be something which is left behind, positive. Therefore, minus 1, and you add the divisor to it, and you call the final answer is going to be 16. That's the beauty there, right? 1 raised to power anything becomes 1. 1 raised to power anything becomes 1. Whereas minus 1 raised to odd power will be minus 1. Will be minus 1. Minus 1 raised to even power will be equal to 1. That would be 1. So that is the beauty there. That's a beauty there. That's what we examined. So odd power we took now. We got minus 1. But I can't type the answer as minus 1. All the remainder problems will never have a negative answer. Add back the divisor. Figure out the positive answer. Okay, that sets the basics for us. That kind of sets the basics for us. Now let's open up to some of the questions which appeared in the kind of exam. Some questions which appeared in the exam. Yeah, let's go ahead. Let's go ahead, put in your answers, use only the properties, then we will scale it up as we go along. Watch out till the end of it. Some beautiful CAT applications will do. Yeah, let's take a look at this. Let's take a look at this. Yeah, quickly reflect, quickly reflect. What is the number? The number is 87 raised to power 88 raised to power 89 divided by 11. What is the remainder? Right, 87 raised to power 88 raised to power 89 divided by 11. What is the remainder? Right, that is the question there. Okay, this whole stuff is the power. This whole stuff is the power. What do? I will take a 87. 87 divided by 11. The remainder is minus 1. Remainder is minus 1. Okay, now author is saying that, man, raise it to the power 88 and 89. Okay, I will raise this also to the power 88 and 89. That's an even number. Therefore, you say that answer is nothing but 1. Answer is nothing but 1. Does anybody need further explanation on this, or did you understand? Did you understand what I wrote? If you want me to cut it down and then explain. I will break it down and explain. No need to break it. We understood, then we will go further. Quickly tell me. Do we need to break this down, or is this clear what we did? Clear, then clear. Put as clear. If we need to break it, we will break it. If we don't need to break it, then we will go further. We understood, understood. Yeah, good. Very good. Hmm. Okay, we'll break the next one, Aman. We'll break the next one. Let's do this also. We'll do this also. Yeah, then we will break, Aman. Okay, we'll break after doing this. Okay, you want us to break, we will break. But let's do this also. All right, guys, your answers quick. Put in your answer here for this question. 30 seconds. It shouldn't take more than 30 seconds. Application question. Just an application in 30 seconds. Give me the answer. Fast. Hmm. Okay. Very good. Very good. Very good. Very good. Okay. See, this is what happens on the cat question, right? Now, this was the cat question. This is what happens on the cat question. All right, now listen, all of you listen. All of you listen. First, tell me what is the value of 2 raised to power 3 raised to power 2? Why don't you put the answer for this? Put the value. I want the full value. All right, I want the full value of this number. All of you put the value of this number. All of you put the value of this number. Forget this question. Tell me the value of 2 raised to power 3 raised to power 2. What is the value of 2 raised to power 3 raised to power 2? What is the value of 2 raised to power 3 raised to power 2? Very good. Very good. That's right. 512 is right. If you knew that, you will not make this mistake. Already, if you knew that, you will not make this mistake. Those who gave one, already know, so you made a mistake there. First, it's a top-down approach. First, you will simplify this. What is 3 square? 9. You write it as 2 raised to power 9. Then you will simplify this, two numbers at a time. Math is always done by taking two numbers at a time. Top down approach. You will see from the top to bottom. It is not that you will chop the bottom. If you chop the bottom, then the numbers will be hanging in the air. Okay, I'm just telling a story. Numbers would be hanging in the air. Don't hang them. You will be doing from the top to bottom. Two numbers from the top. 3 square you will do, which becomes 2 power 9. Now you consider 2 power 9. 2 power 9 is nothing but 512. You will not chop it from the bottom. This is the wrong approach. 2 raised to power 3. You do this. Hey, this becomes 8. Now you will say that I will do 8 square. You get 64, which is wrong. All right, this is utter wrong. This is wrong. Then we say that, okay, law of indices is a mistake. Law of indices is such an important chapter, right? Yeah. Then if indices are the mistake, this is what happens out there. Okay. Let's now come to this. All right, now that is the whole idea. Top-down approach is the question. Listen to this carefully. 47 raised to power 99 raised to power 100. Fair enough. 47 raised to power 99 raised to power 100. First, let me take 47. Okay, the number is for 99. Okay, 47 raised to power 99 raised to power 100 when divided by 8. What is the remainder? All right, first let me take 47 here. 47 divided by 8, preferred remainder minus 1. Okay. Now, what is that I need to do now? This number raised to power 99 raised to power 100. Okay. Which means I got to look at this. Then I should raise it to the power 99 raised to power 100. Listen, 99 raised to power 100 is an odd number. I don't know what is this number. All I know is the parity of the number. It is an odd number. That much everybody knows. 99 raised to power 100 is odd number because 99 into 99 into 99, right? Any number of times, the output is going to be odd. Why? Product of any number of odd numbers is odd. We all know that. How many times you write, how does it matter? For example, if you want to understand it, 3 square you calculate 3 into 3. Whether you write it 3 times you multiply, 2 times you multiply. Product of any number of odd numbers is an odd number. So therefore, I simply say that this is an odd number. I am not interested how big is that. But it is an odd number. That much I know. Okay, fair enough. Therefore, come back and write minus 1 raised to power odd number. What is minus 1 raised to power odd number? Minus 1. But can I say my answer will be minus 1 for a remainder question? No. Then you should add what? You should add the divisor. What is your divisor? 8. Add the divisor and call the answer as 7. Did you all understand this? Aman, you wanted me to explain this. This is what the story is. That's it. I explained the full story. Previous question also same story. Story is clear. This is what the full story is. That is it. No big deal. Clear there? Everybody clear? One, two of you wanted me to explain this. I explain. This is what it is. This is what it is. Simple property, law of indices. Right? We just applied one of the laws of indices, top-down approach. Correct? Yeah. Saurabh, when did you join here? Why did you add 8 means what? Can I have a negative remainder for a question? You all got to listen from the beginning, buddy. Suddenly, if you join in between, so you have to go to the beginning. You have to go to the beginning. I always appreciate when you are there in the beginning. Generally, what I do is I lock the meeting room, right? If I'm taking a meeting on the Zoom, which means if I'm teaching on the Zoom, I lock it. I generally lock it, right? So if I'm doing that, so here it's an open platform. That's a problem. That's the reason I can never hit level 3 here, because I suddenly doing some level 3 and somebody joins in. It's a nightmare, right? Okay, that's a problem with the level 3. So even if I'm taking in a physical classroom, I log them, right? I log the room after 5 minutes. Probably 5 minutes is the grace because people come from different places. That's all right, 5 minutes. But after 5 minutes, it doesn't make sense because they will ask me to repeat, and that will be a loss to everybody, right? Yeah. So anyway, there is a little bit of luxury here on this YouTube. We can't control, but one best way is what technology enables us to go back and listen from the beginning, right? Begin from the beginning. I will just give that suggestion. I don't say that I will not explain. Rather, if I feel that it is more repetitive, I would rather suggest just go to the beginning and do it. Already, you will be fine with it. All right, good. Let's proceed. Let's proceed. Let's proceed. Right. So here come packaging. All right. Now this is called as a packaging question. You got to package sometimes. Other questions were pretty direct. Sometimes you may have to package them before you get your answer. Let's see that what do you mean by packaging this particular question. So you don't need any theorems, etc., etc. You have only two things. All right. Now one, A should be less than D. Point number one. Point number two is quickly look for the preferred remainders in your mind. Quickly look for the preferred remainders in your mind. All right. So therefore, you have to know the powers of threes. A lot of your professors would have said that, hey, learn 3 power 1, learn 3 power 2, like this up to 3 power 6. Because from the exam perspective, you should know 2 powers, 2 power 1, 2 power 2, like this up to 2 power 12. You should know. From the testing perspective, you should know. People simply don't ask you to learn this. They ask you to learn this with a perspective. All right. They ask you to learn this with a perspective. They say already, most of already you would have heard this somewhere definitely by now, because only 2-3 months to CAT. You would have heard this. You have to know the powers of 3 till 6. You should recognize those numbers in and around those particular numbers. You should know the powers of 2 till 12. You should know the square till 25. Despite knowing a technique, you should know the square till 25, because recognition is important. Recognition and then calculation. No calculation at the expense of recognition. I need to recognize few things and then I need to learn calculation further before that, right? Yeah. Similarly, recognition of numbers, all right, with respect to 1 cube up to 15 cube. All right, 1 cube to 15 cube, you should recognize. Because if I fail to recognize these numbers, sometimes the remainder questions might become little tedious. Unnecessarily, it appears tedious. Fair enough. So we understand that, hey, 3 raised to power 5. All right, 3 raised to power 5 is nothing but 243. How the stimulus? I said that more often than not, the stimulus is always the divisor. I said this number won't make sense. What is 3 raised to power 203? No one knows how big it is, what it is. But what I understand, 243, looking at this, it will make some sense to me. Okay, 2 raised to power 5 is 243, which means it is pretty close to this. Let me make the packages of 5. So therefore, 3 raised to power 203 can be written as 3 raised to power 5 40 times into 3 raised to power 3. Isolation technique. Author said that, hey, please divide this by 244. Fine, man, I will divide this by 244 and I will divide this by 244. Technique of isolation. That's what you are using. Use the isolation technique here. This is what 3 raised to power 5 when divided by 243 minus 1. Minus 1 raised to power 40. What is that you are trying to say? 243 what is that? 3 raised to power 5 when divided by 244, remainder is minus 1. The remainder is minus 1. Minus 1 raised to power 40. That's what I did here. Okay, what is 3 raised to power 3 raised to power 3? 27. 27 into 1. Final answer is 27. Is this 27 less than your divisor called 244? Yes, already it is less than that. Therefore, 27 becomes my answer. Fair enough. Everybody clear here? Everybody clear on this? Pretty simple question. You just have to do packaging. Mindfully, you should do packaging, knowing some of these numbers. Knowing some of these numbers, you have to do a mindful packaging and resolve the issue. Do a mindful packaging to resolve the issue. That's it. Clear, everyone? Clear? And then use the isolation technique. Look at the properties, how beautifully we can use. What is the property I used here? Isolation. I did a packaging. I use my preferred remainders. Then I use the isolation technique. right? All these are 30-second questions. Quickly, you will get the answers there. Very good. Very good. Okay. Try this question, everyone. Try this question. 1 minute time for you. Now I will put the timer. In a minute, give me the answer. CAT question. We'll do 3 CAT questions now. Back to back, 2 to 3 CAT questions we'll do. Go ahead. You don't need any knowledge beyond properties I taught so far. Don't think that I need some theorem for it. No. Okay. All right. All right. Now listen. Why you could not do that? Again, all right, now something was missing. What was missing there? You should know that 2 raised to power 10 is 1024. 2 power 10 is a beautiful number. Listen, everybody listen. 2 power 10 is 1024. This is the, all right, this is the benchmark number. So there are certain benchmarks. This is the benchmark number. I was checking that. How many of you remember this benchmark number? That is it. All right, that's all I was checking here. So this was it. The moment you see this question, this benchmark number should come to your mind. 1024. Why? You look at 25, you have a 24. How beautiful it is going to be. And the CAT was testing on the benchmark number. The point is, if you don't know the benchmark number, then what? All it's 1 KB. All it, why it is called as a benchmark number? This is 1 kilobyte. We are living in a digital world. If I don't understand 1 KB, 1 GB, then what do we understand? Right? That's the whole thing there. And this is another beautiful number. This is also nothing but this is the smallest 4-digit number, which is a perfect square. This is the smallest 4-digit number. It is a 32 square. It's also a 32 square. In fact, 1024 is the smallest 4-digit number, which is a perfect square. A lot of things are associated with this number. This is one of the beautiful numbers what the CAT thinks, or any author thinks for that matter. Any author thinks. Fair enough. Okay, I will look at this number. I will package this. 2 power 10. How many times? 19 times. Then I will say that 2 raised to power 9. I can write 2 raised to power 199 as 2 raised to power 10, 19 groups. That becomes 190. Then I will write another 2 raised to power 9. Fair enough. Okay. Divide this by what? 25. Right, divide this by what? 25. Divide the other number by what? Another 25. Right? I will divide this by 25. Isolation technique I'm applying. 25. What is this? What? 2 raised to power 10. I already told you 1024. 2 raised to power 10 when divided by 25. The remainder is minus 1. Remainder is minus 1. Why? Because 2 raised to power 10 is nothing but 1024. 1024 divided by 25 minus 1. Divisible rule for 25. Last 2 digits. 24 divided by 25 minus 1 is the remainder. Fair enough. Therefore, you are saying that, man, this is minus 1 raised to power 19. Because 2 power 10 when divided by 25, remainder is minus 1. This 2 power 10 raised to power 19, then minus 1 raised to power 19. So, therefore, it is minus 1 there. Fair enough. What about 2 raised to power 9? 2 raised to power 9 is 512. Is 512 greater than 25? Yes. Then divide by 25 once again. So therefore you have minus 1 on one side and 12 is the remainder, because divisibility rule for 25 is the last 2 digits. 12 is the remainder. But what is the net remainder, my friend? Minus 12. Because minus 1 into 12 is minus 12. I will not accept a negative number as my answer. Fair enough. What is your divisor? 25. Add the divisor back. Add the divisor back. You would say that 13 is my final answer. Everyone clear about this? Everyone clear about this? Just he was asking about the benchmark number. Your understanding of the benchmark number by looking at the 25. Such a beautiful question. Such a beautiful question. Just that how well we have set our benchmarks. You just have to set certain benchmarks in numbers. You set those benchmarks, things work automatically. Things get triggered automatically. If the benchmarks are missing, that's when the trouble starts. Right? Some of the benchmark numbers. All right. Very good. Everyone clear? Everyone clear? Put it in the perspective. Put it in the chat. Everyone clear? Kritik, I don't know, yaar. All these are LOD 0 or 1, yeah. You call whatever you want. All these are 30-second question. You know the benchmark number. You look at this. 1024 comes to your mind. 25. Mental maths. Technically, some people do this in the mind. Now, sometimes it's difficult to say that this is LOD 1 also. You do things like LOD 1, okay, fine. LOD 0, 1, whatever. I don't know. These are pretty basics I'm teaching. What I'm talking today, I am only talking about 4 properties you learned in the high school. If you think that I want to do a level below this, then it is called foundation. Right? Foundation is not what CAT looks at. Application is what CAT looks like. CAT looks at your foundation. You must be kidding, joking. Right? What they will do with the foundation in IIM Ahmedabad, yeah, they have to select a guy for IIM Ahmedabad. Right? IIM Bangalore, IIMC, one of the top-notch IIMs in the world. Right? IIMs in India and one of the best B schools in the world. With foundation, you get there, you don't. On foundation, you have to construct something. You can't leave it at the foundation. Just like you want to build a beautiful house, you can't leave it at the foundation, right? Foundation is essential. But can I sustain in foundation? No. That's the point. So on the foundation only we are trying to do there. All right, that's here comes another beautiful question. Try this, my friends. Try this, another beautiful question. All foundation questions. Very concept based on those properties. Try it out. Everybody try it out. 1 minute. I want an answer in a minute. Based on only the properties we discussed. You don't need any theorem for this. Yeah, that's right, Devanshi. That's right. That's right. I do one class in the afternoon also at 2 o'clock. You're asking that does my class start at 10, 1 at 2 and 1 at 10. Plus classes will be at different times. I will let you know. Once I plan it, I will let you know. Okay. Listen, again, another benchmark number. This was just talking about another benchmark number. Listen, guys, benchmarks are very poor. I'm asking very fundamental benchmarks today. I'm testing your skills on very fundamental benchmarks. Somewhere you are trying to make a mistake. Listen, all right, 1001 is a beautiful number. 101 is a prime number. Okay, 101 is a prime number. 1001 is a product of 3 prime numbers, 7 into 11 into 30. 1001 is a product of 3 prime numbers. It has 8 factors. 8 factors. It's a beautiful number. And we should know that. Anybody who knew this, they will answer it in 30 seconds, this particular question. Hey, why? What are the factors? 1 is a factor. This 7 is a factor. 11 is this 11 is a factor. This 13 is a factor. Right? Then you will say that 7 into 11 is a factor, 77. Everybody will remember, those who have set this benchmark number 1001 is the benchmark number, right, on the remainders. Not just here, man. All right, now from here I'm going into the deeper side. Anybody who has done the basics of remainders, which means you have gone through some course, then you should know that 1001 is the benchmark number. They're just like 2 raised to power 10 was the benchmark number. 1001 is the benchmark number. It's a product of 3 consecutive prime numbers. Beautiful number. It has 8 factors and you need to know them, because the applications of some of at the deeper stage, the applications, beautiful applications emerge out of this particular factors of this particular number. Fair enough. So you would have noticed this 77. Anybody who was aware of this benchmark number wouldn't take much time to notice this divisor 77, because I said that it's always about the divisor and then triggering to the base of the number. You would have triggered it. Okay, what is the other number? All right, 7 into 13, 91. You should remember this 91 also, because sometimes moment all right, divisor is 91, people fail to recognize. Hey, 91 comes from this 1001, one of the factors. 91 is another mostly used number. Another mostly used number, 143. All right, this into this, all right, which becomes 143. That's another, sorry, this into this, 143. That's another number. Finally, 1001 itself. These are the 8 factors of the number. So we will speak more about this at a later stage, because there is a beautiful story. There are a lot of concepts which emerge. This is 1 day study. This is 1 hour study. The questions built on this or just around this is a 1 hour study, which I don't want to do that 1 hour now. I will do that study. One lecture will be just on 1001 application. Again, not 1001. I will simply waste your time or something. No, I will tell what are the beautiful applications built on this, asked in CAT, ZAT, IIFT, whatever. So what are those kind of applications? We'll speak about it for one full lecture somewhere doing a part of this particular story. We'll speak about it. Fair enough. Anybody recognized it? You will understand that 77 is a factor of 77 is a factor of 1001. 77 is a factor of 1001. Therefore, you say that, hey, 1000 divided by 77, the remainder will be -1. Anybody who was aware that 77 is a factor of 1001 would immediately write the remainder as this. Okay, but author said that please raise it to the power 999. That is what author is saying. Author is saying that please raise this to the power 999. Therefore, minus 1 raised to power 999, which would become minus 1. But I will not accept minus 1 as the answer. Add the divisor and call the answer as 76. Comfortable? Everybody comfortable, my friends? Everybody comfortable on this? Benchmark numbers also I'm talking, and these benchmark numbers were used in the exam uses simple benchmark numbers, thinking that at least people are aware of benchmark numbers. People are kind of aware of benchmark numbers, if not anything. Give a quick confirmation. Are you guys learning something? It is pretty basic lecture, I know, very basic lecture, but is this making sense? Are you guys learning there? I hope I am not wasting your time, especially between 10 and 11 in the night. Neither I want to waste my time nor I want to waste your time. Some learning happening the other side. Is there a clarity on these 3 or 4 properties that we have learned? The way we are considering to apply is bringing some particular clarity there. Okay, well, you need basics also. Okay. I thought that I'm doing the impactful series here. I'm not intending to do too many basics. In fact, I did the basics, no? First 5-10 minutes is the basics only, yeah. First 5-10 minutes the basics. I will do clear basics for 22. I'll be taking a lot of courses on the special as well as on the plus. Right there, I will get a lot of time to do that, every possible level. But for CAT 20, CAT 21, I'll be doing the impact series, and then on the plus, I'll be doing the next 3 months. On the plus, I will be doing level 3 kind of concepts, right? The workshops, level 3 kind of concept. That's what I'm kind of planning there. That's what I'm planning on the plus. All right. So here we go. We'll go to the next one. We'll go to the next one. Try this. Try this. Give me the answer here. Try this. Try this. By now, you should have built sufficient skills and you should be able to answer this beautiful question. All CAT models. A lot of people think that they need some theorems to do that. I wonder, why do they need theorems? Theorems are required, but not for these kind of questions. Okay, I will extend in my mind by 30 seconds. I will count another 30 seconds. Put your answers. 10 more seconds. Okay, do it with me. First, we already said, all right, the base should be, A should be less than D. That is the first thing that we discussed, and we want a preferred remainder, right? A should be less than D. But 110 is not less than 21. Let's do that first step. 110 divided by 21. Therefore, you would say that the remainder is nothing but 5. All right, because 105 is a multiple of 21. Therefore, you say that remainder is 5. Fair enough. But author said that, hey man, it is not 110, it is 110 raised to power 54. Then 5 raised to power 154. All right, 5 raised to power 154. Now it looks better. All right, this looks better. All right, now so this question, is 5 raised to power 154 greater than 21? Definitely, by all stretch of imagination. So therefore, I will divide this by 21 because my answer should be less than 21. This is what you kind of write, 5 raised to power 154 by this. Fair enough. So therefore, what till where you can think 5 square, 5 cube. Okay, whatever you think it is fine. So you think of 5 square, you think of 5 cube. It doesn't matter. All right, no. So what till where you kind of think about it. All right. So let us say that I thought about 5 cube 125. 5 cube I thought, because I can at least go with the multiples of 21. All right, 21 into 6. Right, so it becomes 126. 5 cube gives me 125. Fair enough. So it is 51. So what I'm trying to write here, I'm trying to express this. Listen carefully. This numerator, 5 raised to power 120, 154. 5 raised to power 154. Packaging can also be written as 5 raised to power 3 raised to power 31 into 5 raised to power 1. Something like this. Sorry, into 51 51 raised to power 5 raised to power 1. This is how something I can write this as. All right, very good. So now coming back to this. So now you will say that a 5 raised to power 3 when divided by 21, what is the remainder? Minus 1. Because 5 raised to power 3 is 125. So 125 when divided by 5 raised to power 3 is what? 125 when divided by 21. So 21 6 times is 126. Remainder becomes how much? Minus 1. Very good. So therefore you say that okay, this should be divided by 21 means what? Isolation technique. Divide this by 121, divide this by 121. What is the remainder here? Minus 1 raised to power 51. What is minus 1 raised to power 51? Minus 1. Fair enough. What is the remainder here? 5 itself. What is the remainder here? 5 itself. What is the net remainder therefore? Minus 5. But I will not accept minus 5 as the answer. Fine, not minus 5 is not the answer. Then add the divisor back to this. What is the divisor? 21. Therefore, what is the final remainder? 16. Very, very simple question based on basic properties that we have learned today. Okay, is it making complete sense to everybody? Are you getting control of this? This is very basic, my friends. These are pretty basic questions because we are not using any theorem. There is no mess up here. Pretty simple issue of packaging. Already package wherever it is required. Keep those 2 points, whatever I said in the beginning. Package and apply the property. You just package it and check if any property is applicable, right? Isolation technique, this, that, whatever property is applicable, right? This is a simple skill that they are testing. Therefore, CAT also asks you why you should know theory, why you should do 11th standard, all that stuff. CAT also asks the same question. Common sense is enough to do this question. That is what they say. You did your high school, you did your use your common sense, you will get the answer. Why do you say that the concepts are beyond 10th standard, etc.? CAT has its own defense. They will say that therefore it's a neutral platform, whether you come from arts and literature background or you come from the math background. Doesn't matter to him. Doesn't matter. It's a management program. That's what they say. Right? It's not a math aptitude, it's a quantitative aptitude. So their defense is also right, because for these simple properties learnt in the high school, why do we need higher theorems there? Yeah, somebody knowing it, I'm not saying it is bad. We will learn them because there are some questions. It is good to know those theorems and crack it faster. Without knowing those theorems also you can crack, but it will take longer time. It becomes frustrating. Somebody aware of the theorems becomes easier. That's it. That's all the only difference there. All right. Okay. I guess we are overshooting the time. We are overshooting the time. All right. So if you are learning something, this question I will give it as the homework. This is the homework. I will do it in the next class. I'll do it in the next class. Try it out back home. All right. Just because we are overshooting the time, I will give this as the assignment. One assignment, and I will start with this assignment in the next lecture. Right. I will start with the assignment. So how to deal with this by using these properties, whatever you know. Let's do this assignment. So do it back home. I will not take your answers now. Even if you tell me, you might get the answer, you might not get the answer, doesn't matter. Quick announcements. Listen to the quick announcements. Before that, everybody confirm that you learned something today. Did you all learn something today? It's a very basic class, I understand, but still did it make some difference in your learning? Whatever you know before, whatever you know now, there is some clarity, some difference. Acknowledge quickly. Acknowledge quickly. I just want to know, how did it go? Yeah. Okay, 4, 5 of you understood, 6 of you understood. Very good. Some of made some difference. Very good. Because I don't really want to while away time. That's not the idea. Yeah, because I have to make a lot of assumption about you guys because I don't know much about you guys. So therefore, how what is helping, what not helping. I have to make quite a bit of assumptions. So when I'm checking are my assumptions right? Okay, you need to understand technically why I am checking with you guys is are my assumptions correct? Right? Sometimes the assumptions can go utterly wrong. So therefore, I'm trying to check in that okay, assumptions are fairly around, right? Fairly around. Okay. Yeah, Mr. Hiva, please go back to the beginning of the lecture and do it, man. Do it already. You have time. So lecture videos are anyway there. It is not going to be removed. Please do them. Okay, here we go. Tomorrow again we'll meet at 2ish. All right, now this is today's lectures done. So tomorrow we'll meet at 2ish and we'll continue with our Venn diagram. Not 4 parameters. I think that's a mistake. We already said that, hey, we are going to continue with Maximum, minimum, maybe if there is a time left, we will talk something about Venn diagram for 4 as well. Some applications on Venn diagram, because basics I kind of did already, right? Basics we kind of did already. Yeah, finish. We'll continue with our understanding with respect to the numbers. Again, remainders, we will see factors, etc. at a later stage. Yes, we'll continue our tryst with remainders at 10ish in the night. That's what it is. Yeah, and then we will be doing the free special classes on Wednesday, right? Couple of two free special classes. I'm starting the algebra module there, right? On the special class at about, we'll start at 11 and at 8 as well. I'm starting algebra with inequality. I'm starting with inequalities. There is no standard structure. You may say that start with quadratic. Doesn't really matter what we do. It's an impactful series. I will take a few concepts. I will start from the basic and I will go to the depth of it. All right, that's what we are trying to do out there. I will start with, there are 3 to 4 things to learn in inequalities in depth. So we will talk about those 3 or 4 things, not in one lecture. Of course, we need 3, 4 lectures to do that, right? 1, 2, 3, 4. Maybe it's a sequel. We need that. So if you have not downloaded the app, because this will be done on the Unacademy app, download it. While you are downloading, if it asks for a referral code, use my referral code and you can download that. Yeah, so and you can meet me on the app on Wednesday, right? That's on Wednesday. Tomorrow we'll be meeting on the YouTube as usual. All right, if you have liked the lecture, always express that before you leave. All right, no, so always express that, right? So as I am excited about your learning, so express it. If it is using, all it be it you are watching online, offline, doesn't matter, whenever you watch. So if you like something, there is nothing wrong in pressing the like button before you leave. And you can share it with your friends as well. Let them also join us. We'll work it out together. All right, yeah. So that's pretty much about some of the announcements. Right, yeah. There are some of the educators who have launched the new batches of late, and based on your prep, whether you are prepping for 21 or 22. I will also be launching few batches for 21 and 22, but I'll be doing most likely individually. So you can join me out there. Bucks Bounty, if you find that any inappropriate content while you are going through, not my lecture, any lecture in general on the Unacademy platform, if you find any inappropriate content out there, you can bring it to our notice. How? So you can go to the description. Under the description, you will find the Bucks Bounty there. And from there, you can just bring it to our notice. If you are the first one to bring it to the notice, you will get a prize as well. And if you want to go to my series, what all I have done in the past, you want to take a look at that. So you can again go to the description, go to the description of it, click on the description, you will get the playlist and you can work through that particular playlist. Wherever is your weakness, you can work through that. Okay, yeah, yes, Rishabh. This weekend I'm doing a session on VRC. How to improve VRC? I'm doing a session this weekend on Friday. Friday at about 6:30. I will share how I have improved, how quite a few of us, those who those who took some advice from me, have improved. If particularly very weak, I will speak about that. How to do it very practically. Some practical tips that worked in the past, I will share it. Okay, that brings me to the end of this particular lecture. Anything that you guys want to share, you can quickly share it here. Otherwise, if somebody has missed it, the beginning part of it, please go to the beginning of it, watch it from the beginning. I will see you guys tomorrow afternoon at 2. I will see you guys tomorrow afternoon at 2. Bye till then. Yeah, I'll see you guys at 2, 2ish in the afternoon. Yeah, who is asking? So you are asking the Telegram group. This is the Telegram group. Yeah, yeah, this is the Telegram. This is the Telegram group. I will put the notifications out there. Good night, friends. Good night. Good night. See you guys tomorrow afternoon. Bye till then. Stay blessed. Sleep well.